Hi, we're just doing a quick video that explains a little bit the basic idea of this paper by Musa Blimpo, Sean McRae, and Jevgenis Steinbucks. Why are connection charges so high? Analysis of electricity sector in Sub-Saharan Africa, right? And I think we'll get a lot of our intuition of understanding what's going on in this paper just by taking a close look at the abstract, always what you want to do when you're reading a paper. So this abstract is not quite as clear as it could be. And what's important to note in the abstract is this sentence. So they're going to start with this word from regulated electricity tariffs, by which they mean the electric rate, the cost to the consumer of electricity, the tariff to the consumer, how much the consumer has to pay for electricity. These rates are regulated and they're set too low. And so what follows in the paper, what the paper is arguing is what follows from this. So this is the beginning, is number one, is we have electricity tariffs are set too low. And the implications of that is that utilities lose money on each connected customer. So because the rates are too low, the utilities lose money on every connected customer because it costs them more to provide the electricity than they can collect from the customers. Because of that, the utilities try to limit how many customers are on the grid. And so the utilities charge high connection charges. So the rate is set by the regulator. That leads the utility to be unprofitable to serve new customers. And so the utility responds by charging high connection charges. If you want to become a customer, you have to pay a big upfront fee. That then means that there are few customers, and that's what we call low electricity consumption. Low electrification rates. We might go down to here. So we have low electrification rates, and the low electrification rates is what makes the utilities lose money. So we have kind of a circle in the analysis. The low tariffs mean that utilities lose money on each customer. Because they lose money on each customer, they charge high connection rates. Because they charge high connection rates, they have few customers. And one of the reasons then they have high costs per customer is that they have few customers. So that's the vicious circle that many electricity providers in Sub-Saharan Africa are caught in. Now, an ancillary finding of the paper, essential to them sort of explaining this vicious circle, is that households that are connected or might be connected have very low willingness to pay because they have alternatives. They have kerosene for powering, kerosene lanterns for light, and generators for small, pumping of water for small irrigated areas. And so their willingness to pay is low. And so that's why electricity will only spread partly when incomes become higher. When incomes become higher, the demand for electricity goes up, the willingness to pay for electricity goes up, and then it won't be as unprofitable for the electric providers to expand. And so they'll start expanding, which then lowers the marginal cost of delivering electricity. And that's the virtuous cycle that electric providers want to be on. So that's the paper basically in a nutshell. The paper then consists of an exploration of the maximization problem of the public utility that is confronted with a rate that's set by the regulator. If the rate is set by the regulator, then how much should the utility's connection charge be if the utility is trying to maximize profits? Well, that depends on a variety of parameters, and the most important of those parameters is what would be the take-up rate of potential new customers for different connection charges, and where would those customers be located? Would they be located in low service cost areas or in high service cost areas, from the point of view of the provider? So the authors are trying to carefully estimate what the likely take-up rate is for different connection charges given the usage rates. And as many of you noted in your commentary paragraph, sometimes the usage rates are two-part tariffs, where you have a fixed rate for a certain amount of electricity and then a higher rate for more usage. And that kind of two-part tariff is very common in electricity markets, because electricity providers face what's called the peak demand problem. They have an installed capacity for electricity generation. If the demand exceeds that installed capacity, like in the United States, we have really, really hot days, everybody turns on their air conditioning. The Electric Power Authority doesn't have enough electricity to power everybody's air conditioner if they're all on at the same time. And those kinds of peak demand situations often will cause failures of the electric grid system. And to avoid that, then you want to charge people a lot more during those peak periods to reduce the likelihood that everybody will be using electricity in those peak periods. So that's the two-part tariff that electric providers often lobby for, and most economists and most citizens would agree is sensible. So they try and estimate what those consumer demand for electricity, both its usage and whether or not to connect, would be. So that's why you have two different estimations. One is what would be the usage rates for different prices, and the other is, given the usage rates for those prices that a consumer expects, would a consumer even make the connection? And of course, that depends on the connection charge itself. Pretty straightforward paper, actually. It's hard to parse sometimes because it has a lot of modeling and stuff. A lot of really useful information. I encourage you to go back and take another look at it and think about it in terms of any kind of publicly provided utility service, or even privately provided utility service, has all these same issues. So to that extent, it's a very general paper.